So this is very exploratory at this stage, and mostly we're using social networking data with spatial data of check-ins. But the additional dimension here is that we know the connection between those who are checking in. So there's social influence, and we're examining the role of that social influence in the spatial choices that individuals are making. Okay. Where am I? Okay. All right. So there's some kind of framing that, or the motivation in terms of the from a travel behavior perspective, is that you know, one's opinion or judgment plays an important role in screening relevant alternatives for consideration in one's choice set, and of course social data or social influence is an important element of that. So what we're looking at here is trying to capture the effect of social connectivity on individuals' choices of destinations. Okay? There's been some work in the literature examining the effect of social interaction fairly recently, I would say, and I would point to the work that Andy Frey did with Kai Axhausen in Zurich. But most of that work has been based on surveys using what you could think of as static data, and we're still in the early stages of the use of such information in our choice models. Okay? So one of the questions, for instance, is whether if you look at the sort of choice sets of different individuals, whether the fact that a particular destination in a friend's choice set is now likely to be considered by a person. So is the inclusion of this activity, or the likelihood of including a particular location in one's choice set, then affected by the fact that it belongs to a friend's choice set, and that's part of the motivation of what we're trying to capture. Now we're using a defunct social network. It's called BrightKite. The reason we're using BrightKite, and which is available through the Stanford website for these types of information, is that we could really get access to all of that data fairly easily. Okay, it's all there, and there is no restriction on its use essentially, and it's not huge, okay? And so even though it's big data, we're really here doing sort of more of the artisans' work on it. You know, we're still trying to understand what individuals are doing. We're not simply, you know, sort of looking at the aggregation of all of these patterns. So there's both elements. Of course, we're still hoping that you can, in fact, dissect individual travel patterns from this kind of data, even though we don't know anything about them. Okay, we don't have such demographics. We don't know, you know, much about. We don't have the information that you normally would have from surveys, and we were able to essentially obtain check-ins that they had in the Chicago area. This is downtown Chicago. This is Evanston, where Northwestern University is. So we're kind of familiar with this area. So we have, you know, better chance of understanding what they're really actually doing in that area. And so the examples of, well, this is what the data, you know, actually looks like. Okay, so you have the lat and lon of the check-ins. You have the time, and you have the user number. But we also know how these users are connected. We know they're friends. Okay, and now this is not. I mean, we're talking. You know, 2008, 2010. So it's. Yes, social networks were there, but they had not exploded to the degree that they have today. And one could argue that today you're likely to probably capture an even a much larger fraction of the population when you look at that type of information. So we do know, again, for each, how the users are connected, and so you can establish arcs between the connected users. We also, later on, one of the analyses we did is that we weighted that connection by the number of common destinations that they visited. Okay, so we could create communities based on shared destinations among friends. Okay, and this is the social network characterization, where you look at sort of the relative frequency of travelers who have friends, essentially in terms of the number of activities that they perform. In that data set, the number of check-ins vary from a minimum of 1 to a maximum of 8640, with a mean of 6 and a median of 1. The number of friends also goes from none to 96. We only looked at people who had friends. If they didn't have any friends, we didn't consider them ultimately. And the number of locations that are visited, that went from 1 to 2100 over the period. Of course, this is self-reported, so the frequency is going to vary by individuals, and that itself may be reflective or as itself a source of bias in what we're looking at. So here are examples, okay, of, this is our selected users and where they have visited. And in looking at these users, we typically take so the size of the circle reflects the frequency that they have visited a particular location. We take the largest circle to be their home location, essentially. Okay, so that's considered their home base in our analysis. Again, we have no way of really confirming that, but in our analysis we treated that consistently. Okay, so that's the point that they come back to most frequently in the records that we have, and so on that basis, that's where we picked up their home locations, and you can look then at the locations relative to that home base. Okay, and these are circles. The red one is 10 kilometers basically from the home locations, and these are 4 different users, and you could see essentially where these locations fall within relative to their home base. Of course, there's an early theory that would say that everything has to be in an ellipse, right, in terms of the different destinations. We're not necessarily seeing the ellipses here. The patterns are different, and we think that with this representation, we're kind of able to characterize the different patterns, the fingerprints, if you wish, of their spatial locations. Actually missing the top of my title, but it's okay. I know what those are. Okay, this is looking at the distance distribution of the check-ins and the home location, and the x-axis is the great circle distance, going up to 30 kilometers here. And what's interesting is you can fit sort of a nice power law function there, and so you could the power law parameter there is negative 1.83, again giving you a decreasing probability of visiting a location as a function of its distance from the home base. And this is looking now at where the friends' homes locations are relative to your own home base. Okay, so this is now where your friends are, and again, a sort of a power law there function seems to fit with a value of negative 1.5 in terms of where your friends are. Okay, not too different, in fact, from what other locations might be. So we've looked at the distribution of joint check-ins. Okay, so whether the the pairs of friends, if you wish, have how many of the pairs that we have had one common destination up to 20 common destinations, and this is what the distribution looks like. Obviously, there are many more that have one or two common destinations versus having 20 destinations. And we found also that the number of check-ins increases with the number of friends that you have. And I'll show you some further information later. And as I said, we took a measure of betweenness, which is weighing that arc connecting friends by the number of common check-ins or common destination that they have, and the following communities then emerge when you cluster when you cluster data on that network. In fact, up to 111 communities emerge in this case over the 13 or 1400 users that were in our data set. Each the colors correspond to different communities. And what's interesting, the biggest community is the one that you have here. This is community 2, that includes the most individuals based on the common destinations that they visit. Okay. Now, we did a simple a regression of a negative binomial regression to look at the number of check-ins as a function of the number of friends that you have, and also the number of locations visited as a function of the number of friends. And in both cases, more friends means more check-ins, more friends means more locations visited. So it checks out. Now, one of the things we also looked at is the temporal pattern. Do you check in before your friend, essentially, or after your friend? In other words, who's leading, who's following, sort of thing. And this is just for one user. And what's interesting is that in 55% of 35% of the cases were before, 30% were after, and 35% where was no influence. So it was pretty well balanced in this case. There were other cases where you're always where 90% of the time you're checking in before your friends. Other cases that are different. So no particular patterns there, but that's one of the aspects that we tried to explore. Then we looked at their the sort of how these were changing dynamically. Okay, so if you again we're looking at here are the this is okay for one user, and I'm going to try and do this online, see if I succeed with this. I guess we're not connected here. You're not connected. Okay. All right. So too bad. If I connect later on, I'll try to show you. But essentially what we show for each user is the dynamic sequence of the different destinations. So where they over the whole duration of check-ins, and you can see where they go back to, how frequently, distances, and so on. So it's a really nice animation for each individual user. Okay, this is looking then here at distance from home, hour of the day, and the frequency of the destinations that are visited. And again, without the animation, it's not as easy to look at. This is looking at the projections of looking at distance, an hour of day, and this is looking here at the frequency by time of day, essentially for each user. Okay, and so. With these, then the challenge, of course, is to know what were those destinations. And this goes back to the very interesting presentation that we heard earlier, because, of course, you don't know what these destinations are, and you have to infer. Okay, so we did that. We actually inferred that, and I believe. Ying Chen, who's a PhD student working with me on this, ultimately used the Foursquare categories. Okay, so given that we have the locations, we were able to map them and infer the categories. These are the location IDs and what the different, whether it's residential, industrial, restaurant, commercial, coffee shop. I don't think there were any cemeteries that day, but. Yeah, yeah. And so we did that, for every for every user that we had in our database. Again, this is another example, looking at the categories, and then we examined with this community that I mentioned to you that was identified through the clustering. We looked at the all the common destinations for that community, and of course you can, if you click on the Google map, you can get the addresses, and that, it's easy to explore from that standpoint. And if I were connected, I would show you how you could use this dynamically. And so for that community, what we found was the classification of the destinations. There was 1 coffee shop, 3 sightseeing, 15 amusement locations. So this is again the categories of the destinations that were common to that particular to that community. Okay, so what do we do with all of this ultimately? So we study destination choice modeling, and it's fine. Of course, you can't totally generalize because it's the known biases of working with self-reported information. But it is spatial, it is dynamic, and so you could study both temporal and spatial pattern, as we tried to do here, to kind of visit some of the hypotheses that that travel behavior folks have looked at for some time, and also to examine the role of social influence. So clearly what we found there is that people are more likely to go where their friends go. Okay, so that was, and that we could test fairly rigorously. And but we also found that people are more likely to go where they go. Okay. In other words, if so there's a very strong influence of you repeating the destinations that you go to, even more so than going to where your friends go. So the sort of telic effect is stronger in this case. But one neat application that Ying has in fact recently developed is to come up with a meeting location recommendation model. Okay, and so I know your spatial, I know your check-ins and mine, or I know somebody else's check-in, then we can help identify where's a good place to meet. So but maybe for some of the dating services, if people volunteer their check-in information, then you can identify good meeting locations. So this is just for 2 people, where you take the pattern for one, pattern for the other, and then you could actually identify what would be good meeting locations, places that they both go to, without necessarily knowing it. In other words, these are not joint check-ins, but they have gone there at different times. And 55 to 60% of the location, the sort of joint locations, were typically bars and coffee shops and things like that. This is, again, still fairly early, but in this model, I mean, there is actually a utility model. There's something that's optimized to give you sort of the best recommendation and the second best, and so on. And but that's, as I said, it's still in the early stages. Nothing, I think, that has yet commercial potential, though it may be a nice little app that people can play with on Facebook or Yelp or whatever. And so anyway, concluding comments, as I said, it's an exploration of destination choice behavior using location-based social network check-in data. Clear evidence that friendship status influence people's destination choice. Travelers, as I said, are more likely to visit places that their friends had previously visited, but the likelihood of returning to locations previously self-visited is actually stronger. They're more likely to check some locations that are clearly a proximity effect. Number of friends significantly influences their travel behavior as it was measured here. Again, how you generalize from this is still very much open to question at this point. And when it comes to anomalies, obviously within this context, one of the challenges that I would add is when to know when a seeming anomaly is in fact not an anomaly. And there are many instances of that in this context and others. So thank you.
It's very nice. I'm curious, were you able to tease out any mode information from this?
No, there's no travel.
No,
There's only destination
choice.
choice.
But it would be kind of interesting if you could potentially determine how these people are moving from point to point.
It would be, yes, I completely agree. We did not have that information there. I guess with the complete GPS information, we may be able to get that. But in this case, we did not. That's a very, very good point. Yes.
So how do you deal with the temporal resolution of those check-ins? So one thing that we found challenging for that kind of analysis is that while people explicitly check in, there's no check-out functionality. So the system, or most systems, have this 2-hour rule that if you are at the place for 2 hours and you don't log into another place, they lock you out. So the minimum temporal resolution for all your inferencing, so to speak, has to be not smaller than 2 hours. How do you?
We did not study duration. So, I mean, that was not an issue here, but you're absolutely right. We don't know exactly when they checked out, so we could not study these factors. All we know is they went there. And the main thing that we focused on really in here was more of the social influence with that information. That was the main motivation for us, was the social influence and looking at the jointness that we get and whether we can construct useful communities with that kind of data.
Oh, yeah, a general question. Both of your presentation and others we've heard, both of your presentation and the others we've heard, it strikes me that within the past few years, we've all of a sudden gotten lots more information to confirm, basically to confirm things that you sort of got no influence travel behavior and destination and all that stuff. Yet there's still a huge gap between now this explosion of information that we know will help and the models that we have to apply. And how do you see, because I know you've done, your life is modeling, right? How do you see closing that gap?
You know, that's a really good point. I think we do that in steps, ultimately, and opportunistically. I think we're really close with this kind of data to be able to move to a modeling stage. What's really missing here is the kind of sort of personal revealed type of information that you would need to get from a survey so you know more about that purpose and so on. There are data collection examples where people provide that information, but it tends to be relatively small scale. You know, let's go to pragmatic issues. Okay? Agencies are not in the business of funding the collection of that kind of data. Okay? So the reason we get this data is because there's commercial value in it. Okay? So if we can essentially get the commercial value of the information that we need, then we would have that information and we could construct some of the wonderful models that are then the activity-based models and so on. So in that realm, I think there's still a gap to be bridged, and perhaps and this is bringing in even more noisy data, but tweets, for example, are a source of information that might help us learn more about what people were doing or how they were engaging. Our initial attempts to analyze tweets have not been very successful because of somehow people don't talk very much about transportation when they tweet. We talk about other things, and so we were not able to extract very useful information from that.
It was.
On the other hand, there are other areas now where we have, as in traffic modeling, okay, where we have put to use that explosion of data, all this, the sensor data that PEMS and so on has given us, increasingly probe data and what have you, all of that now is systematically used to create clusters. And these clusters are, these patterns that are created now are the basis for, certainly for online forecasting and so on, as well as for creating scenarios to test various things. So in that realm, I think we've moved further. When it comes to behavior, some things are still missing.
All right, thank you very much.